Ken Weller here with new Tech Inventors, and today we're moving along with the print farm. We're going to be getting power to these printers and to our sub panel for the first time. But before we connect the power, we've got one more thing to do. We have two surge protectors that we want to install in our panel. The reason we have two surge protectors is that it takes one for each phase of the power coming in. And since this is a two-phase panel, we will connect one to a breaker that's connected to one phase, and we'll connect the other surge protector to a breaker connected to the other phase. It's pretty simple. The white and the green wire goes to your ground, and the black wire then goes to the appropriate breaker. And once the surge protectors are installed, they have indicator lights that will let you know if they're functioning properly or if they've been damaged. So let's get to it. Okay, as you can see, I've added my main breaker here for the sub panel. And we'll go ahead now and turn power onto our sub panel and go see if we've got some power in there. Okay, got a jigsaw hooked up here, no power. Turn breaker 1 on. Got power. Now, our surge protectors are on this breaker. It's checking good. And on this breaker, checking good. Now, the reason we have one on this breaker and this breaker is because this is one phase, this is another phase. So you have two phases here, this 110 coming in, making 220. So if I hook into this breaker down here, this is phase A, phase B, phase A. Okay, it's on A. Phase A, phase B. This breaker is on B. I want a surge protector on each phase of this power. So we've got both of these surge protected. And these indicators will let us know that they're working properly and are still good. If something happens and we have a tremendous surge and one of these goes out, these LEDs will no longer burn. Okay, now we've got our panel finished. We've got power coming to it. We have to be very careful now because everything in here is hot. We want to get it on get the cover on as soon as possible, but I'm leaving the cover off because if you remember, I told you that I wanted to be able to check the actual current being drawn by these printers. And by having these individual breakers, I can check them individually. If you notice, I put a big curlicue in these main wires coming in. The reason for that is so I can clamp my amp meter onto these wires and check and see what the current is. The same thing on my neutral. Also, these wires coming out of the breaker, I've got them pulled forward so I can get a clamp on each of them and check the current to each one of these circuits individually. Let me say one thing, caution. Anyone that is fooling around with a panel or anything, unless you have a lot of experience, never fool with these things with the power on to them, and unless you really know what you're doing. I'll go into it later, but I have had a lot of experience with this. I know what I can touch and what I can't, but I try not to touch anything that I don't actually have to, because there are some points here that are very hot at all times. 220 volts, definitely at 100 amps, enough to kill you. So if you don't know what you're doing, get a professional. Don't take any chances. Okay, now we're going to connect the power cords to these 6 printers here in Bay 2. Bay 2 is powered by breaker 2. And once we get all of the cords plugged into the printers and into our little terminal strip, we'll be ready to go over to the panel and turn that breaker on and power these 6 printers up. And we'll be doing some current checks on them just to see how much power they're actually going to be drawing, both peak power when they're preheating as well as the runtime average power. So let's see what we've got. Okay, I've got all of these plugged into our power strip. These 6, we're going to do a power test. We're going to come over here to the breaker panel. That is breaker number 2. Turn on breaker number 2. And that should give us power here. And we do have power. Now, what we're going to do is go ahead and power up all 6 printers. Looks like everything is powered up. Okay, now we're going to go over here to our panel and let's see. Put this thing on 200 amps and 0.8 on that phase, 0.2 on this phase. Okay, 0.01 or 0.1. This is 0.4. So what that's telling us is that these 6 printers are drawing 0.4 of an amp. Now we're going to put them in a preheat mode. I'm going to put the camera down so I can try to get them all preheating at the same time. I'm going to cut the lights down. I can't hardly. Okay, now I got the lights down where I can read these things a little better. Okay, let's start preheating these. Okay, they're all preheating. Let's go over here and see what we're drawing. Drawing 10.4 amps. 10.4 amps. That is the maximum power that this circuit, this 20 amp circuit, is going to have with these printers connected. Because as you can see, they're all still preheating. None of them have reached temperature yet. So they're drawing the maximum current for both the bed temperature and the head. And there's 6 of them on one circuit. So at 10 amps, you can see that they're drawing a little bit less than 2 amps each in a heating mode. Now, as they start getting to temperature, once they start getting to temperature where they're just having to maintain that bed and head temperature, then you're going to see a reduction in the current draw over here. So let's go over, it looks like some of them are reaching temperature now. Let's go over here and see if our current's dropping. And yep, we're down to 9.4, 8 point, jumping back and forth between 8 and 9. The reason it's jumping around a lot is because even though some of them have reached temperature, they're going to be cutting on and off and on and off to maintain that temperature. But you can see we're dropping as low as 5 amps there at times. There's 6.4. Once everything gets fully preheated, we'll be able to see what the pretty much what the average current draw is going to be in a run operation. We're already jumping around a lot here between 4, 5, 6, 7, 6, 5. I think you get the idea. Let's go back over and see if everything's preheated now. It's this, the last one we did. Yeah, it looks like everything is preheated and maintaining temperature. So this should be a good example of what the current draw is going to be. And you can see now we're down to 1, 2, 4, 5, 6, 4, 3, 2, 5. So I'm guessing the average current draw is probably, when it's running, we're probably going to be around looks like around 4 amps. Yeah, an average somewhere around 4 amps. So when we talked in some other videos, we were talking about, I did a video on how much power does your printer need. Well, you can see 6 of these, if you fire them all up at exactly the same time and put them in that preheat mode, they're going to be drawing about 10 amps. However, once they get running, they're not going to draw anywhere near 10 amps. They're going to be down around 4 amps while they're running. So that's something that we wanted to know for sure, and that's what we'll base. We'll look at the averages, we'll fire up more of these, and we'll actually have all 24 of these printers running and checking the current at that time, and that'll give us a better average, I think, of how much cost we're going to have in power, or how much power consumption. The other thing we're going to have to deal with is heat. And like I said, I've never had as many printers in one room like this running. So as I start adding printers in here, we're going to be monitoring the temperature of the room. And I have some electronic thermostats that I'll be using, and they'll be used to control these 2 vent fans up here. And I'm also going to put a third one in where this louver is here. These others are for air intake. And we'll be able to switch those fans, vent fans, on in stages. I think I'm going to try to maintain a temperature, an operating temperature in here of about 85 degrees. And it's important, as most of you know, that the ambient temperature affects the print job. So all of these print jobs are going to have to be tuned to a particular ambient temperature. So that's why I figure it might be best to, and easier to, maintain an 85 degree temperature or possibly even 80. I haven't decided for sure yet, but it's not, I'm not going to try to maintain 72 degrees in here, because in the winter time with the printers running, they'll produce enough heat that I won't be required to have any heat down here. And in the summertime, we will have air conditioning in the other room, and it will take some of that. I don't want to have to run the vents any more than I have to, because as I'm sucking air out and exhausting air, I'm drawing outside air in, and I don't know what the humidity of that air is going to be, and it might overwhelm the dehumidifier I have running here. So I may have to put in a couple more dehumidifiers to keep up with it, but we'll just have to play that by ear. But I wanted to show you how we're doing it. Everything's still nice and hot, preheated, and we're coming over here and we're looking at the amperage that it's drawing, and it's staying right there around, really it's averaging closer to 2.5 now, it looks like. So anyway, so much for now. And just to show you another thing too, I don't know if I explained it, but when I put this panel in, I put these loops here, and I was waiting for somebody to ask me why I did that. Well, this is exactly why, so I could get my meter on there easily. You can see we're not drawing anything on this other side. It's showing 0.1, but that's just a static reading. It's showing that when we're out here. So we're not drawing anything on this phase. This breaker is all on this phase right here. So that's the only one we have to check to see how much current we're drawing. So that's good news. At that rate, if I run 6 printers off of about 2.5 amps, then I'm looking at running these, all of these, at probably around 10 amps in the run mode. So that's not bad at all. I think in one of the other videos I talked about when I was running 14 of these Anets in some King rooms all at the same time, and it blew a 20 amp circuit. Well, I had a computer and some lights and other things on that 20 amp circuit at the time, including the printers, and I was in the process of preheating 8 of the Anets. So you saw 6 of them here preheating, drawing 10 amps. So if I had 8 of them, it would have been drawing probably about 12, 13 amps, in addition to all the other printers running and everything. And that's why that circuit breaker tripped on me. But I'll give you some more information as we go along on the power draw and everything. I still have a couple more Centronic and a couple more Anets to put together. I've got some ET4s, 2 more ET4s I need to put together to go up here, and it looks like I have one more printer to go down here. Then we're going to start with the Tronics on racks on this other wall over here, and also some of these are some of the ones that I ran up at the house. They're the P802 Tronics printers. I'm going to cut my lights back on here. You can tell it makes it a little hard with the glare to read the display, but it sure does let you see the print job and everything that's going on. So that's what I wanted to show you. I'm going to go ahead and power these things down, let them cool down a little bit, and get back to work on assembling some printers.